This is part 3 of the spring final exam review. Once again, I encourage you to try these on your own and using the answer keys on Canvas. However, for those of you that need extra instruction, this will go through every problem on this review. So first off, find the following attributes of the rational parent function 1 over x. Now, if you take a look with me on the graph here, if we remember 1 over x, it has this basic shape, and it's two separate pieces, if we remember that. So the domain, we'll graph that more accurately in a minute, but I wanted you to see the basic shape to go over domain and range. Let's do C first, C and D, the asymptotes. With these functions, with x in the bottom, we have an asymptote at y equals 0, that's the horizontal line, and x equals 0, that's the vertical line. So the vertical asymptote is x equals 0. Horizontal asymptote is y equals 0. Why am I starting with this? Because it's very important to notice that as our graph goes from, as our graph goes from left to right, we remember we will never actually hit the asymptote. So there is a break there when we have an asymptote. We will never touch the asymptote. We're just going to get infinitely closer to it. What that means is when I get the domain and I'm reading it left to right, we're going to stop at 0. So our domain is, set notation, remember, is the squiggly line. We go from negative infinity to 0, and then we use, let's write this in a different way. We have x is less than 0. Then we use this u, which means union, because it's two separate pieces, and we have x is greater than 0. X is less than 0 on this side, and x is greater than 0 on this side, but it will never be 0 because of that asymptote. Interval notation, and then we close it with the other squiggly line. Interval notation, we would go negative infinity to 0, union, 0 to positive infinity. Then inequality would be exactly like set notation, but without the squiggly lines. So x is less than 0, union, 0, then x is greater than 0. For the range, same idea, but we read it down to up. When we start at the bottom, we'll come up, and then we will not hit 0. We're going to jump over it and then continue because of that asymptote. So the range is y is less than 0, union y is greater than 0. Interval notation, negative infinity to 0, union 0 to positive infinity. Inequality, not x. Y is less than 0, union y is greater than 0. Now end behavior. End behavior we know is x gets bigger, 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 or smaller, smaller, smaller. In this case, is x increases, which is to the right, or decreases, which is to the left. Either way, we notice these end pieces are getting closer and closer to 0. They're getting closer and closer to our horizontal asymptote. Now let's graph this a little bit more accurately. So we know about our asymptotes. When I plug 0 in for x, if we were to try this in the calculator, 1 over 0, we would get undefined. Why is that? Because the denominator of any fraction, it's impossible to divide by 0, so we cannot have 0 on the bottom. So if x is 0, y is undefined. What if I plugged 1 in for x? That would give me 1 over 1, which is simply 1. So I have the point 1, 1. And we should know from our basic shape that we just drew that we're going to hug the asymptotes and go through our point. When x is negative 1, that gives me 1 over negative 1, or simply negative 1. So I have the point negative 1, negative 1. Hug our asymptotes, and there's the graph. What we should notice is those 2 points that we got, they lie in diagonally across sections from our asymptotes. That should always be the case when x is on the bottom. So number 2 is no longer the parent function. Problem number 2 is now transformations and all that other stuff. So when it comes to transformations of a 1 over x function, our x transformations are on the bottom of the fraction. As we know, x is live, so that minus 3 means shift right 3. Now, the top part is the same as our multiplier out front. I could have just as easily written this as negative 2 times 1 over x minus 3 plus 4. 2 different ways of writing the same thing. You need to be ready for either of them. So that negative out front, no matter which way we write it, means reflect over the x-axis. The 2 means vertical stretch by 2. The plus 4 is a shift up 4. So that's transformations in a nutshell. Let's worry about domain and range last because I want you guys to see it on the graph before we do that. So the vertical asymptote, that's the one that goes up and down, that will always be our denominator. We set it equal to 0. We get x equals 3. Therefore, our vertical asymptote is x equals 3. And it looks like that on the graph. The other way to think about that is our left and right shifts. Notice we shifted right 3, so we went plus 3. Our vertical asymptote is x equals 3. The horizontal asymptote will be our shift up or down. In this case, we shifted up 4. So our horizontal asymptote is y equals 4, which on the graph is right there. Remember, end behaviors, even before I graph this, our end behavior when x is in the denominator will always approach our horizontal asymptote. So in this case, it is 4. For the table, we could just graph this in the calculator, and that will give us our XY table. And again, this is so we could determine which points go in which sections of the graph. And if you give me 1 second here just to confirm my math. So some points we get on the graph are 1, 5, 2, 6. At 3, it's undefined. because of that asymptote. And as we see, if I were to plug in 3 in our function, this part would give us 0 on the bottom, therefore it's undefined. And then we would get the points 4, 2, and 5, 3. So 1, 5, 2, 6. That tells me that our graph is in this direction in this shape. Then the points 4, 2, and 5, 3. That tells me the graph is in this section. So there's our graph. The domain and range, just like before, domain is with set notation. Set notation means that squiggly line. Domain, if we were to go left to right, we're starting at negative infinity, we're going to jump over 3 because of the asymptote and then continue. So we have x is less than 3 union, then x is greater than 3. Interval notation is negative infinity to 3, union 3 to infinity. Inequality would be x is less than 3, union, then x is greater than 3. The range, we read down to up, so it's going to start all the way at the bottom, jump over 4, and then continue up. So that's y is less than 4, union y is greater than 4. An interval notation, negative infinity to 4, union 4 to positive infinity. Then inequality, y is less than 4, union y is greater than 4. So we will continue this video. We will continue this part in a second video. Due to time restraints and lack of ability to record more than a certain number of minutes, we would not finish this video in time. So the second half of this video will be posted shortly.